in Malaysia is a traditional medicinal plant said by Louis et al. 2024. It has a bit strong antioxidant activity with high phenolic content in its leaf, said by Sim et al. The problems that we are trying to solve during this research was that the P.Bleo plant is not well studied and have little knowledge about Aqueous extraction method. The second one was not much studies about emulsion water in oil used in cooking oil. And lastly, the VHD content in cooking oil is harmful to human health.
Our first objective is to extract P.Bleo leaf using the aqueous extraction method. The reason why we choose the aqueous method because it is safe, environmentally friendly, and does not involve harmful chemical solvent, thereby preserving the natural properties of the plant. Next, to identify the most suitable natural emulsion for combining the aqueous extract of P.Bleo with peanut oil. Here, we also evaluate the stability and suitability of the resulting emulsion using natural stabilizer such as soy lecithin and xanthan gum. On the other hand, this study is to compare the effectiveness of P.Bleo extract with VHD, which is synthetic antioxidant commonly used in the industry. The purpose of this comparison is to assess the potential of P.Bleo extract as a safer and more effective natural alternative in preventing the oxidation of peanut oil. Through these three objectives, we aim to create an effective, safe, and user-friendly natural formulation, particularly for application in food and health products.
Result of extraction aqueous P.Bleo hour is 16.22%.
Subsequently, we developed 8 emulsion formulations to the test efficacy of different stabilizer and extract types. As you can see, the variable include the use of wet versus dry P.Bleo extract and different stabilizer, specifically xanthan gum and soy lecithin at varying concentration. Most importantly, after comprehensive analysis, we identified that formulation 4 demonstrated the best formulation. This optimal formulation utilized a wet extraction method of P.Bleo combined with soy lecithin as the stabilizer. From our extraction process, we obtained a crude oil yield of 39.36% directly after screw pressing. Following a subsequent isolation and purification step, a final yield of 33% was achieved, which represents the full oil used in our subsequent formulation.
For the FFA test, the oil sample was mixed with alcohol and titrated with sodium hydroxide. The higher FFA means the oil is getting rancid or unstable. For the PV test, the oil was rigged with potassium iodide and titrated using sodium thiosulfate. The lower PV means the oil is more stable and less oxidized. Both tests were done before and after frying to compare oil with and without P.Bleo extract.
This is our result, FFA and PV. Our impact and contribution of our study. The first is replacement of synthetic preservative with a safer alternative. The second is sustainability, utilization of local resource. The last one is enhancement of product quality and shelf life. Our studies can contribute to SDG 3, 9, and 12.
To summarize everything, the extraction yield that we obtained was 16.2%, indicating the extraction was successful but moderate extraction efficiency, and the crude peanut oil yield that we screw pressed ourselves was 32.99%. Next, the most successful formulation was sample 4, which contained only oil and the extract. It happens because the extract has its own emulsifying characteristic, making it possible to mix with the oil. Lastly, we did the acid value and peroxide value analysis. The initial acid value percentage for crude peanut oil was 1.6%, and after adding the extract, the percentage decreased for 35.98%, and after frying, it decreased for 42.23% from the initial. Next, peroxide value initial percentage was 12.81%, and after adding the extract, the percentage increased 2.81% from the initial, and after frying, it decreased for 22.56%. This has proven that the P.Bleo extract can be used as an antioxidant, but it still needs a few modifications as this research used crude peanut oil and not refined oil.